Neutron stars, the most extreme objects in the universe. The universe is filled with extraordinary objects, but few are as strange, powerful, and mysterious as neutron stars. Imagine a star so dense that a single teaspoon of its material would weigh billions of tons on Earth. A place where gravity is powerful enough to bend light, warp space, and compress matter into forms unlike anything we experience in everyday life. These incredible objects are known as neutron stars. They are among the smallest stars in the universe, yet they are also among the most extraordinary and extreme objects ever discovered. But what exactly is a neutron star? How does one form? And why do scientists consider them some of the most fascinating objects ever discovered? To answer these questions, we first need to follow the life cycle of a massive star. Every star begins its life inside a giant cloud of gas and dust. Over millions of years, gravity pulls this material together until temperatures become high enough for nuclear fusion to begin. A star is born. For most of its life, a star remains stable. Gravity constantly pulls inward while nuclear fusion pushes outward. This balance keeps the star alive. But eventually, the fuel begins to run out. For stars much larger than our Sun, a violent and spectacular ending awaits. When fusion can no longer support the star's enormous weight, gravity takes over. The core collapses in a fraction of a second. The outer layers explode into space in a massive supernova. For a brief moment, the explosion can outshine an entire galaxy. What remains after the explosion depends on the original mass of the star. Some become black holes, others become neutron stars. Inside a neutron star, gravity is so powerful that electrons and protons are crushed together. They merge to form neutrons. Matter is compressed to unimaginable densities. A star that was once millions of kilometers wide becomes a sphere only about 20 kilometers across. Yet it can contain more mass than our Sun. Think about that for a moment. More mass than the Sun packed into an object the size of a city. This makes neutron stars some of the densest objects in the known universe. But density is not the only thing that makes them extraordinary. Many neutron stars spin at incredible speeds. When a star collapses, its rotation speeds up dramatically. Some neutron stars rotate dozens or even hundreds of times every second. These rapidly spinning objects are known as pulsars. Pulsars emit powerful beams of radiation from their magnetic poles. As they rotate, these beams sweep across space like the light from a lighthouse. When one of these beams points toward Earth, astronomers detect a pulse of energy. That is why they are called pulsars. Some pulsars are so precise that they rival the accuracy of atomic clocks. Scientists use them to test Einstein's theories and study the nature of gravity itself. The magnetic fields of neutron stars are equally astonishing. Some possess magnetic fields trillions of times stronger than Earth's. These extreme objects are known as magnetars. A magnetar's magnetic field is so powerful that it could affect electronic devices even from enormous distances. Fortunately, all known magnetars are safely far away. Yet even from those distances, they can release tremendous bursts of energy. These eruptions rank among the most powerful events in the universe. And despite everything we have learned, neutron stars still hide many secrets. In the next part of our journey, we will discover what would happen if a neutron star approached Earth, how neutron star collisions create gold, and why these objects may hold the key to understanding some of the greatest mysteries of the cosmos. But the story of neutron stars becomes even more fascinating. What would happen if a neutron star approached Earth? The answer is simple: nothing good. Even from a great distance, a neutron star's gravity could begin to affect the orbits of planets. If one somehow entered our solar system, the consequences would be catastrophic. Its immense gravitational pull could alter planetary paths and destabilize the entire system. If Earth came too close, tidal forces could stretch and tear our planet apart. Fortunately, there are no known neutron stars heading toward Earth. Yet studying these objects helps scientists understand some of the most extreme conditions found anywhere in nature. Neutron stars are also responsible for creating some of the rarest elements in the universe. When two neutron stars collide, they produce one of the most powerful explosions ever observed. These events are known as kilonovae. The collision releases enormous amounts of energy and creates heavy elements such as gold, platinum, and uranium. In fact, scientists believe that much of the gold found on Earth was created during neutron star collisions billions of years ago. This means that the gold in jewelry, electronics, and even some scientific instruments may have originated from a cosmic collision long before our solar system existed. In a very real sense, some of the atoms around us were forged in the violent deaths of stars. But neutron stars may hold even deeper secrets. Scientists still do not fully understand what exists at their cores. The pressure inside a neutron star is so extreme that normal matter behaves in ways we cannot completely explain. Some researchers believe that neutrons may break apart into even smaller particles known as quarks. If that happens, the center of a neutron star could transform into an exotic object called a quark star. No one has ever confirmed the existence of a quark star. Yet the possibility remains one of the most exciting ideas in modern astronomy. Neutron stars have also helped scientists explore one of Einstein's greatest predictions. In 2017, astronomers observed the collision of two neutron stars using both telescopes and gravitational wave detectors. For the first time in history, humanity was able to both see and detect the ripples in space-time produced by a distant cosmic event. This discovery opened a completely new way of studying the universe. Instead of only observing light, scientists can now study the universe through gravitational waves. Every new neutron star collision provides valuable information about gravity, matter, and the structure of space-time itself. And despite all we have learned, many mysteries remain unsolved. How many neutron stars exist in our galaxy? What truly lies at their centers? Could quark stars actually exist? And what other secrets are hidden inside these extraordinary objects? Future telescopes and scientific missions may provide answers, or they may reveal entirely new mysteries that we have not yet imagined. That is what makes astronomy so exciting. Every answer leads to new questions. Every discovery opens a new door, and every journey into the cosmos reminds us how much there is still left to learn. Neutron stars are not simply distant objects in space. They are natural laboratories where the laws of physics are pushed to their limits. They challenge our understanding of gravity, matter, energy, and the universe itself. They remind us that the cosmos is far stranger, far more powerful, and far more beautiful than we could ever imagine. Thank you for joining us on this journey through one of the most extreme objects in the universe. If you enjoyed this documentary, don't forget to like the video and subscribe to Hidden Universe for more incredible journeys through space, time, and the mysteries of the cosmos. Until next time, keep looking up.